Hey everyone. Today we're going to dive deeper into logarithms and their use, their purpose. Today we're going to learn something called the change of base. So the warm-up is evaluate the following logarithmic expressions, and we're going to try to see which ones we could do without a calculator and which ones that we need a calculator for. So the first one, log base 2 of 128, is 7 because 2 to the 7th is 128. The next one, log base 10 of 1,000 is 3 because 10 to the third power is 1,000. So we can do that. But what happens if it's a base that we don't know 5 to what exponent, what power is 100? Okay, today we're going to learn how to do this. Now, I'm very aware that some of your calculators have the base button where you can change the base. But we're going to learn that everything should be converted to base 10 or to the base of a natural log if we're dealing with base e. So how do we deal with this? So we're going to learn how to change the base, how to convert it from base 5 to base 10. So let's assume that we don't know what it is. So log base 5 of 100 equals x. Step 1, we're going to convert to an exponential because maybe that might help us. So 5 to the x power equals 100. Okay, I don't like that. So I'm going to take the log of both sides. We're going to see in a minute exactly why I just did this. And you're going to start seeing if I have an x in the exponent, I'm going to take the log of both sides. And then I'm going to use a property that we've just learned about, the product property. So the product property says if this x is in the exponent, we can really move it somewhere else. So power property of logs says I can move the x out front. So x times log of 5 equals log of 100. And these are both in base 10. Now I got to undo the multiplication, so I divide both sides by log of 5 to solve to get x by itself. So log of 100 divided by log of 5. So log base 5, can't use a calculator for it, but these both in log 10. Okay, base 10. So use calculator, log base 10 of 100 divided by log base 10 of 5, and we get our answer. So we get 2.86. Now, the problem may say convert into base 10, and then we just leave it as log of 100 divided by log of 5. Or it may say evaluate and round your answer, and that's how I get 2.86. So what the change of base formula says, the theorem says if I have a base, any base, so log base b of a, I can change it by doing the log base anything of a divided by the log base anything of b. Now, I don't know why you'd ever use any other base besides 10 in this case, so we're just going to assume c is 10 and just say that log base b of a is really log of a divided by log of b, and they're both base 10. Then you can use your calculator to evaluate it. So that's how we change the base from anything to base 10.